Welcome back to Munro Live, everyone. My name is Tyler Schlink, and today we're going to be talking about the Ford F-150 Lightning Instrument Panel, otherwise known as an IP. You've probably heard us say IP a bunch of times in other videos. That stands for Instrument Panel, and it's basically the dashboard of the car. Many other people just call that a dash or a dashboard. It's evolved quite a bit. I believe dash was originally the term used for like the front of a horse-drawn carriage or a sleigh to stop the horses from dashing up dirt onto you as you're riding behind there, and it's kind of just carried over. But it's, as you can see, not a insignificant system. It's very complex, and I've actually just spent the better part of the last month tearing this down and costing it and doing assembly processes for it. This is a very traditional IP for the F-150. Very traditional in that it matches a lot of the way cars have been being done for a decade or two. So there's not a whole lot of riveting things about it, but that's also the neat thing. On Munro Live, we always like to maybe show you the latest and greatest and the eye-popping features and stuff. But in this case, we're going to take a little break. I'm going to pull some of the stuff off here, which is going to be a little laborsome, and we're going to build it from the cross-car beam up, so you can see, kind of the general public doesn't get to see normally how an entire IP would come together. And along the way, I'll point out the interesting features and maybe the not so interesting or not so efficient features of this particular IP. But if we take a little break, I think we can get into it. All right, so here we are. We got the magnesium cross car beam that is on the F-150 Lightning. As you can see, probably in the B-roll, I already threw a couple brackets on here. Now, we've probably not shown a lot of cast magnesium cross car beams on Munro Live, but it's something that Ford's been doing for a while. They've been heavily invested in lightweight magnesium materials for a while. I believe like their transfer cases and stuff had, I think they still do, but at one point they had magnesium housings on their transfer cases. So they've worked with suppliers, and it's a really good lightweight material, but you pay for it. Now what's interesting about this though is that, as you can see, I put on three metal brackets. There are, I believe, upwards of 12 to 15 of these brackets all over this. It begs the question, is it worth sticking with magnesium if you're just gonna put 12, 14 brackets on here? Because you're paying quite a bit for it, but all your light weighting efforts go out the window. It might be cheaper, to just go ahead and if we need 12 brackets anyway, let's just make this all out of an old school steel tube and weldments and weld it all up. That's what many IPs look like before some of these hybrids came around. This right here is the Rivian, for example. We've shown Tesla doing stuff like this. Mercedes has been doing stuff like this. Maybe BMW. Of course, Rivian. Now this is the extruded aluminum cross-car beam with overmolded plastic. And as you can see, they clamp around the extruded aluminum here, and they have injection molding tools that put all of those plastic ribs on it. And you essentially have the freedom to design whatever type of brackets and reaching out mounts you want. And it's all done in one or two injection molded shots. That begs the question, if we're going to do cast magnesium and you already have that freedom to put all this shape and geometry into it, is it worth it once you put 10 plus metal brackets back onto it? As far as a weight comparison, that Rivian right there weighs, I believe, 5.5 kilograms. This magnesium cross car beam weighs 5.8 kilograms without any of the metal brackets. So this one weighs 0.3 kilograms less, and all the brackets are already on there. I'd have to do the weight calculations to see how much more weight gets added from the 10 plus steel brackets that go on there. But of course, the F-150 is a bigger vehicle, so it makes sense that it weighs more, but I think you get the idea. Okay, so moving a little bit further forward, I'm going to do another bit of assembly for you and show you something that I found a little bit interesting being the guy who has to cost the assembly process of this thing. So just one of the many brackets I was talking about happens to be kind of like a support strap. So I think that this item right here perfectly kind of summarizes this IP as a whole. And what it is it kind of shows it's a good IP. There's a lot of unique things about it. They put in the larger screen that's in the Mach-E. They use cast magnesium. There's optimized things about it, but it's just not all the way there in terms of efficiencies. There's kind of a lot of afterthoughts and buttoning up. And what I mean by that is you have a support strap that goes on here. You would think with cast magnesium, you could mold all the structure you need into this casting and just be done with it. But it seems like that Ford had to come through and add a little bit of extra structure. This is the only purpose this bracket serves, is to kind of link these two geometries together. So that's one sort of inefficiency. And on top of that, if I'm the assembly operator, I got to put this thing together. That's part of what I was tasked with costing on this. I have 2 different bolts that go in here, and it's quite easy to mess up. So let's run that one down there. Okay, that one goes into a metal J-clip. Now this one, I'd love to go ahead and run it down again, but it doesn't fit. I need a 10 millimeter socket head for this one. But you got to do that on 10 plus brackets, and you might actually make a mistake here. So as we move further into the IP and I take some of these plastics off, you'll see there's a lot of nice, thoughtful stuff in terms of balancing cost and efficiency, but you also every now and then see stuff where it's just like, you could have made that extra left, you could have commonized the fasteners, you could have maybe integrated these things, and that kind of perfectly summarizes this IP as a whole, but we'll get into that. All right, so kind of moving on, we're now going to take another break as we get all the plastics onto here, and you'll see when we pull these big plastics on here, that's another thing to consider is, you see plastic bracket mounting points here. Another thing I was considering is, you could maybe stick with the cast magnesium, because it probably offers a lot of structural benefits. I know that's something I didn't mention before. Jordan and Kevin did videos on the front end structure of the Rivian, and they mentioned a lot of redundant load paths that might be a little over-designed on the Rivian. And that, being an interior guy, sometimes I don't take the body structure into consideration, and you definitely have to consider that this cross-car beam structure does work as a whole with the vehicle, and maybe Rivian's able to go so lightweight on the cross-car beam because there's already so much structure built into the body. It's definitely not out of the realm of possibility that the Ford F-150 uses this heavier cast mag as almost part of their structure of the body and their crash grip and accepting crash loads and stuff like that. So I definitely don't want to just poo-poo on it with the tunnel vision of just me being an interior guy. But as we flip this over, I think we can start pulling some of these plastics off and get a little deeper into the IP. And as you can see, it's a full-time job just to get all these things organized on here nice. So it's going to be a little bit of a half-time job, part-time job to get it back on the table. So we're going to take a little break. It's the end of the day. I might even be wearing different clothes when we come back.
17 hours later.
All right, and we're back. I have removed as many parts as I could. I think we're going to build up about the half of this thing, maybe just the right-hand side. And we'll start with the IP carrier itself. So this is called the IP carrier panel, or the carrier substrate. If you can think about it like building a house, the cross-car beam would be considered like the foundation, and then this would be considered maybe like the framing and the studs on the wall, the stuff that you're gonna hang all your decorations on and whatnot. So if we flip this over, we'll see that we have some HVAC ductwork. Now the HVAC on this vehicle is actually mounted to the body in white. Sometimes HVACs will be mounted to the cross car beam and will come off with the IP. Not the case in this vehicle. It's pretty common on trucks to have the HVAC case actually mounted directly to the firewall over there. You can see way in the background. So the only thing that's got to be built up on this particular carrier substrate is just the ducting. Now this is the main ducting that blows the air on the upper side of the occupants. And this is made out of high density polyethylene, HDPE. It's basically, the same thing milk jugs and stuff are made out of. It's actually made with a blow molding process, a lot like milk jugs. They'll have material ready to go, and they'll close up kind of like an injection mold tool and blow air on the inside and kind of fill the void. Can't really control the thickness of the material very well with this, but it's a nice cost-efficient process to make ducting, especially large ducting like this. This would be mounted down on the carrier substrate. There's definitely little pokey locating features all the way around. Let me go ahead and put a screw in here. Now throughout this assembly process, there's going to be a lot more screws and installing than I'm going to do, but I'll just kind of put enough to hold things together. Now this carrier substrate, if you talk to Carl, you've seen him on our channel before, he's liking the more modern approach certain vehicles are taking of, rethinking the need for a carrier substrate in the first place. Can you integrate this with your A-surface materials all into one unit? And that's kind of what we here at Munro try to preach is integration like that. But this is definitely not uncommon. Many vehicles on the road have a carrier substrate like this. So we walk through this thing one more time. This interfaces with the HVAC case. This is where all your outlets go. As I said, this is kind of like your main airflow, but here would be your defroster and your demister. This is what blows air directly on the windshield or the door panels in order to kind of get frost or fog off your windshield in the morning. So this is another high density polyethylene ducting. You can see very simple construction, just wrapped with a foam. And these are just inserted together, and that kind of just seals off the airflow. And I would put on the other side, but unfortunately the other side, the way this IP is assembled, it can't be installed until after you load it onto the cross car beam, which is another one of those little inefficiencies that I find kind of annoying when taking this thing apart. And I'm sure from the assembly standpoint, it's less efficient. And actually, before this carrier substrate would go onto here, one of the most important parts of the assembly, and it's the first thing to happen after they put these brackets on, that is the installation of the wire harness. Now I'll give some pictures to Josh here to throw up on B-roll. The wire harness it's quite a complex bundle, and it's installed from the back side, and there's a lot of snap fits to get it in place and a lot of fishing of wires. It's actually it's a bit of a monster when you see it, but most instrument panels are like that. I'm going to avoid doing the electric harness today, so but that would be actually what goes on before any of this plastic top hat stuff would go on. So at that point, once you got all your ducting hooked up, drop it in over those brackets, and it kind of falls right into place, which is really nice. Now you've heard me say the term poke yoke. That's essentially, it's a Japanese term for essentially mistake proofing. Something can only be assembled one way. You want to design things so they can't be installed incorrectly. It makes kind of the thought process behind building it much quicker and efficient. An example of that, I actually forgot to do it before we put it on here, but this steel bracket actually goes onto this panel before it goes on here. And if, yep, there's little snap fits right here. It's easier to do it while it's on the ground. But if I needed to snap this into place, I couldn't do it this way. The way it's designed, the snap fits are offset and it doesn't fit correctly. So I couldn't install this incorrectly anyway, unless I flipped it around. And then it would actually line up. It would allow me to snap that into place. A lot easier to see if I had that on the floor, but you get the idea. So that's the general IP carrier. This is made of polypropylene glass filled. I believe this is a glass filled 30. Now the reason you would use glass filled polypropylene on something like this is it's a couple reasons. One, polypropylene's about the most cost efficient resin you can use, and this is a very large, as you can tell, very large injection molded panel. And so if you're using more expensive material, of course, that's more cost. Now, polypropylene isn't the most structural material, so that's why they add glass to it. The glass filler doesn't really affect the cost any, but 30% glass filler basically allows them to make this a more structural and rigid plastic injection molding. And another thing glass filler does is it reduces the amount of shrinkage. So every time you mold a plastic part, there is a little bit of shrinkage that goes on in that. And if you imagine a part this big, 1% of shrinkage on something this big is that's more than 1% of shrinkage on a small part. So putting glass filler in here also reduces the shrinkage, which would be a lot more on a part like this. So that's another reason to use glass filler. So the next piece that would be going on would be little ancillary support pieces, stuff that they couldn't necessarily mold the features into on the main carrier substrate itself. This right here would be called like a glove box support housing. And specifically why they had to make this separate is because of the way they install their glove box and putting these little molded features in there. I'm actually kind of a fan of that, and I'll show you here very shortly. Ford's been doing this style glove box for a while. This usually just snaps into place, and then of course there's there are screws that go in here. Now when we talk lean design though, one of our lean design philosophies at Munro that we try to preach is design for manufacturing, design for assembly. Anytime you install something, you try not to do more than one motion. You want stuff to go down in one direction, and then any fasteners also go down in that same direction. In this case, bugs me a little bit, but you put in fasteners in this location, but there's just one extra little fastener that has to go in over here on the side, just a little extra guy, even though there's a snap fit already done over here. Now we see stuff like that all the time on IPs. IPs are not the easiest thing to design and assemble, and I believe Carl's even mentioned this in other videos. Like, we are very nitpicky in these videos, and we don't tend to point out the good as much as we point out the bad, and that's just by nature of our job here and trying to find efficiency improvements. So you'll hear me talk about stuff like that. So as I mentioned, I do like the way the simplicity of the glove box assembly on most Fords these days. These molded in little rounded features here just accept this snap fit for the glove box. And the installation of the glove box is actually, if you have an F-150, a newer one I believe, you could go pull off your glove box in seconds and reinstall it in seconds, which is really nice. You line up all three of those and it just snaps into place. Of course, if everything was assembled with all the screws, it would be a lot more rigid than that, but it just folds up into place and locks in. And if you ever needed to change like your HVAC air filter, it's as simple as pulling open your glove box and popping those out of there. Like I said, it's kind of flimsy right now, but it is truly as simple as just snapping these into place on here. Now on this particular vehicle, they also have what's called an upper glove box. A lot of the trucks are doing that these days for, of course, more and more storage. Sorry, I could have took the bags off there. This one, if you see, there's two little locators down here to make sure this is assembled correctly. Those will actually fish down in there, and once they find their location, sit right into place. And little note on the material of this is a glass-filled nylon, which I thought was very interesting. Glass-filled nylon is not the cheapest plastic material, and this doesn't necessarily seem like it has to be structural in nature. Like, they use polypropylene, EPDM-filled polypropylene throughout most of their instrument panel, I believe even on this glove box. But this upper one, they use is glass-filled nylon, which seems a bit overkill. And on top of that, they even painted it. You can see in here, it's probably hard to see on camera, but you get up close, it looks like this is all painted a surface color, which is to probably try and match the color of the rest of the IP, which is made out of mainly polypropylene based stuff. This would be a very difficult thing to paint. When you spray paint, if you have any experience with that, you get a lot of pressure buildup and blowback in something like this, unless you used a very low pressure nozzle to get in here and paint all that. So it seems a bit, it just doesn't match the surroundings, right? If we're willing to go with just mold and color plastic on like your main glove box, why wasn't it acceptable to do it maybe on the upper glove box? So a bit of extra cost thrown into the upper glove box, which is unexpected. Now, another thing with lean design philosophy, I know snap fits and elimination of threaded fasteners is something that Sandy talks about quite a bit, and it's polarizing for sure. You have to think about your serviceability requirements, and some things it makes sense to snap fit, some things it makes sense maybe if you don't design your snap fits right, after you pull it off 10 times the snap fits break. But I want to just give an example from a design for manufacturing standpoint, why we preach well done snap fits that are designed with their tolerances and everything perfect, so you can pop them on and off all the time, even on stuff that doesn't need to be removed. This is a classic example. So this is the upper glove box. This is going to be the push button mechanism for that. Now you can imagine if we had to screw all these things together, what that would take. But when it's as simple as 3 parts all snap fitting together, I can show you from a design efficiency standpoint how much easier it is for operators to make these vehicles at the hundreds of thousands when the assembly is as simple as just that, with no tools needed. Now, kudos for a design for manufacturing type button setup, but what's interesting is when you come over to where this button gets mounted, you do all that wonderful design engineering for easy assembly, and then you have to use 3 screws to put it on the back of this trim panel for the air vent. This would be the upper glove box door. The little push button right there, which is spring loaded with another foam seal, loads right down into that first duct we put on. That first duct we put on, this basically nests right down in there when snapping into place. And so now you're starting to get a general idea of how we went from, you know, a skeleton that just looked like a bunch of metal and plastic and what's going on, to getting to that top hat layer, the finished design. There would be a chrome bezel here. All right, so the next type of piece we're going to talk about is these actual leather wrapped decorative trim panels. These are made from a polycarbonate ABS blend. Now, polycarbonate, PC ABS as they call it, polycarbonate's probably the same thing that like CDs would be made out of, that very brittle but very strong clear plastic. ABS is the same thing that like Legos are made out of, so a very versatile, one of the most versatile plastics that kind of have all the great properties of them. So this is a blend of both of those, often used for decorative plastics that need to be kind of rigid so they can be wrapped well. And also PCABS is able to have glue sprayed on them to put this wrapping on without needing to do any plasma or flame treating. Stuff like this for the assembly is as simply as just snapped into place. That's how the operators kind of snap them in. I know I'm missing a couple things around here, but you get the general idea. Then you got your topper panel. Now in this case, for a $90,000 vehicle, this is probably the most controversial part of this IP. This is just hard mold and color plastic. On similarly priced vehicles, you would probably find that this whole top piece would be wrapped, and so when you're sitting in the passenger seat or in the driver's seat, you could reach up and touch that. So this is a truck though, you have to think about it that way. I'm not so picky about stuff like that. It's an F-150, there is some nice touches here and there. I'm a little on the shorter side too, so I'm not always reaching up to touch the top of here. I'm okay with it. It's a cost save. It helps bring down the cost of the EV, which with the electric powertrain, it's already you know, tough to make money on these vehicles, as we all know. So you gotta cut costs where you can, and I think they did it effectively on this F-150. Now this topper pad also has the airbag on it. I'm just gonna get this on the ground here so we can see. These airbags these days are very simple for operators. They would put in hooks on one side, load in the hooks on the other side. There's a couple little extra brackets I don't have that also secure it into place. When this gets inserted, these will actually lock into the magnesium cross carbine. It becomes basically a structural component, obviously, as it's necessary, but for simple assembly standpoints, this is nice to be able to pre-assemble it onto one of the finishing surfaces here. Snap, fit, and screws just like everything else. They'd hook up the wire harness as they brought this down and put this into place. Snap it down. I haven't hit all the snaps, of course, but I'm just giving you an idea. And then the final trim piece would snap into that. So it is important, the order of operations of assembling these things. I couldn't put this final piece on, of course, until this was put on, and then that's put on just because of the layering. So another thing that I think about a lot when I'm doing these teardowns and doing the assembly and costing mapping in terms of efficiency. How can we layer these panels differently? So that's the general buildup. You can see how it's starting to look like a typical IP in your car. The only other thing we have here is a lot of the electrical modules, a bit outside of my expertise area, but radio would get inserted down in here. Driver monitor system module would be mounted in there. A lot of modules are usually mounted in the center stack. And then we have, of course, the wonderfully big screen, the same one that's in the Mach-E. What I think is cool about this screen, I can't talk about it from a software or an EE background, but I can talk about it from just a general neat design concept. Now, when I first saw this vehicle, the rotary knob, dumb me, I thought it was probably built into the screen. Maybe they had to have a custom screen and it went through the screen. There was a hole in the screen. They'd have to interact that button directly with a PCB board. Not the case. It is literally just a glued on button, and I'm sure it's laying around here somewhere. You can look up on the internet. But it's just a glued on button with a haptic feedback on the back. It's basically just acts like a human finger. And so when you push the button in, it's just like your fingers touching the center, and when you rotate the volume knob up and down, it's no different than me doing that with my finger, and they just built that into kind of the software of the touch screen. So it's kind of a nice hybrid to give the haptic feedback button that is a polarizing thing. When Tesla doesn't have any buttons and it's all on a screen, some people want just some buttons, maybe just for a quick volume or just for quick turning on and off. And it's a nice hybrid thought to execute that without really making your touchscreen any more expensive by doing some crazy engineering on it. So I've always thought that was unique. But that's basically it. I know we could talk a lot about an IP, but since this one's not so, there's not anything from a technology standpoint that's new to the industry. I figured that this video would just be maybe better served showing our viewers how much effort it goes to take into putting in a major system in a vehicle, but it is just one of many systems in a vehicle. And hopefully you learn some stuff. Hopefully I explain myself clearly. I'm enjoying doing more and more of these Munro Live videos. I'm glad Sandy and the team lets me hop away from my desk. That's just right behind you over there. But I'd probably be yelled at by Corey if I didn't say, please subscribe. We're a growing channel, and we're loving doing this every day. It makes my job very fun. So thank you, and take care.